Hello, and today's purpose of the day is I can add and subtract rational expressions. For a warm-up for today's lesson, please find the following examples. Add or subtract the fractions. What do you get when you add 3/4 plus 5/16? Well, let's take a look right now. So in order to add 3/4 and 5/16, I need a common denominator of 16, so I will multiply the first fraction by 4/4 so that I can make sure I get 16 in the denominator. And again, I have to multiply both parts of the fraction by 4 because I must keep it equivalent. So 4 times 3 is 12/16 plus 5/16, which is 17/16, which translates into 1 1/16. What do you get when you subtract 4/3 minus 2/3? Let's go through the answer. Well, it has a common denominator, so what's 4 minus 2? 2 over 3, so that one was very simple. What about number 3? 9/10 minus 3/4. Well, you have to get a common denominator between 10 and 4, but 4 does not go into 10 evenly, so you must figure out what both 10 and 4 go into, which is 20. So I would multiply the first fraction by 2/2 to get 18/20, and then multiply the second fraction by 5/5 to get a common denominator of 20, and I get 15/20, and 18/20 minus 15/20 is 3/20. Let's use those skills of adding and subtracting fractions to now add and subtract rational functions. So we need to find the sum or difference. The big thing we need to remember is in order to add fractions, similar to rational functions, we need to make sure to have a common denominator. So let's look at example number 1. 8c/6 plus 5c/13. Since I have a common denominator of 6, I can go ahead and add my like terms in my numerator. 8c plus 5c is 13c all over 6, and that is my final answer. Pretty simple. Let's look at the second problem. 3x over 3 plus x squared over 3 plus x. So when I look at this, I have a common denominator again of 3 plus x, so I can go ahead and combine my numerators. So I get 3x plus x squared over 3 plus x. Now I can take this a step further and I can go ahead and factor out a GCF of the numerator of x and then get 3 plus x if I undistribute all over 3 plus x. And now you can see some terms that can cancel out. The 3 plus x over the 3 plus x simplifies, and I'm just left with x for my final answer. Example number 3. So let's take a look. I have a common denominator of 15 minus x for both my fractions, both my rational expressions. So let's go ahead and add together the numerators. So 17x minus 2x is 15x. Positive 4 minus a negative 6, chop is really plus, 4 plus 6 is 10, all over 15x minus 5. Now I can go ahead and factor both the numerator and the denominator here. So with the 15x plus 10, I can factor out a 5, and then get 3x plus 2. And in the denominator, I can also factor out a 5 and get 3x minus 1. Now the 5's cancel out, so my final answer and what I'm left with is 3x plus 2 all over 3x minus 1, and now that will be my final answer. And I am not allowed to cancel out those 3x's because I would need to take out a 3x out of every term. The 3x out of the 3x, the 2, in the denominator 3x, and the negative 1, and since I can't do that, this solution here is in its simplest form. Let's take a look at a few more examples. Example 1 on this slide. X squared over x minus 3 plus 3 over 3 minus x. Well, these denominators here look very similar, but they're actually not the same because if I rewrite them, x minus 3 is not the same thing as negative x plus 3. Those are not the same. However, do you remember what these are called? Terms that are very similar that differ by a factor of negative 1? You got it, additive inverses. So what I need to do is I could actually change one of my denominators to appear like the other denominator if I factor out a negative 1. So if I factor out a negative 1 from this fraction, and I'll zoom in here, So I zoomed in a little bit so we can see this better. So if I factor out a -1, I need to bring that to the numerator. So now that becomes a -3, and then this just becomes x minus 3, right? This x would change to a positive x, and this would change to a -3. Both the signs would change if I take out a -1. So now I really have x squared, and I'll rewrite this, x squared minus 3 all over x minus 3. Now can I factor anything out? I cannot. This is in simplest form because, again, if I wanted to, I'd have to take it out of all 4 parts of this fraction. So that is my final answer. All right, let's look at example 2 on this page. 2x over x minus 1 minus 2x over 1 minus x. Again, we look and we see that our rational expressions here almost appear to have the same common denominator, but differ just by -1. So let's change one of the fractions, or one of the denominators of these fractions to turn into the other. And again, when I say fraction, a rational expression. So I'm going to take out a -1 here, bring it to the numerator, so that changes to x minus 1. So now what I have here is 2x over x minus 1 minus -2x over x minus 1. So I see a double negative, so that turns into a positive. So 2x plus 2x is 4x over x minus 1. And again, I can't simplify any further, so that is my final answer. Again, make sure, even if you have an additive inverse, that you have a common denominator so you can go ahead and add or subtract those rational functions. Let's take a look at LCMs, least common multiples. This will help us for today's lesson, and it will also be a preview of what will help us for tomorrow's. So let's find the LCM, least common multiple, of 6x and 4x squared. So let's factor completely 6x and 4x squared. If I factor completely 6x, that's 2 times 3 times x. And if I factor completely 4x squared, I get 2 times 2 times x times x. Now we have to figure out what the two terms share and what's the least common multiple that both 6x and 4x squared go into. So the number will obviously be a little bit higher than probably 6x and the 4x squared. So let's look. They both share a 2, and they both share an x. So we only have to write that in our least common multiple one time. So I'm going to write that here. So it must have an x and a 2. Now the 6x also has a 3. The 4x squared doesn't, but I need to include that in my answer because the 6x has at least that. Now, the 4x squared also has a 2 that the 6x doesn't have because we already included one of the 2's in there. So we also must add now a 2 because the 4 had 2 of them, the 6 only had 1 of them. So I need to make sure I include everything that I can. And we already canceled out these x's. We got that 2 and that 3, so now there's one x left over that is in the 4x squared that must also be in the least common multiple that 4x squared goes into. So we have to add another x. So we have to make sure we include everything that is in both the 6x and the 4x squared, and they might share a little bit of overlap, which they did. They shared a 2 and an x, so we only had to write those once. So this LCM would be 2 times 2, which is 4, times 3, which is 12, x times x, which is x squared. And 12x squared is the least common multiple that both the 6x and the 4x squared go into. All right, let's look at this next example here. So let's find the LCM, or least common multiple, of n squared plus 5n plus 4 and n plus 1, the quantity squared. So let's look and see what this first trinomial factors into. So factors of 4, that would added together give me 5, are 4 and 1. So this factors into n plus 4 times n plus 1. And this over here, this n plus 1, the quantity squared, factors into n plus 1 times n plus 1. So if we need to find the LCM, I need to figure out what goes into both of these, and then also add what the extras are in of both of them. So they both share an n plus 1, so I only need to write that one time. So now those are canceled out. Then this first one also has an n plus 4, so I have to include that. And this one over here has another n plus 1, so I need to include that. So the least common multiple that both of these terms go into is n plus 1, and I could say the quantity squared, because there's 2 of them, times n plus 4. And I could write my answer in either way here. It doesn't matter, they mean the same thing. But that there would be the LCM of n squared plus 5n plus 4, and n plus 1, the quantity squared. Thanks for listening. Have a great day. Bye-bye.